Welcome to S1 Lesson 7, Discrete Random Variables, looking at expectation and variance. Let's quickly recap where we are in the S1 syllabus. So at this point in time, we've covered probability, we've done the introduction to discrete random variables. In this video, we're going to look all at the expectation and variance and everything that we can do with the expectation of variance. And that will complete the discrete random variables topic. Expectation. The expectation is the average outcome or the mean. And this is best explored through an example. Let's look at example 1. The number of people in a car are recorded in the table below. We want to find the mean number of people per car. Now, as we know, the mean is the total of all data divided by the number of data. So if I just add a total onto the end of this row, and then I can add the 280 to 300 to 164, 52 and the 4, and I get a total of 800. Okay, so that's a total of 800 cars. Now what I want to know is the number of people in the cars. So the number of people can be calculated by doing the number of people per car times by the number of cars. So 1 times 280 plus 2 times 300 plus 3 times 164 plus 4 times 52, and then finally plus 5 times 4. And I'm not going to bother with the last one because there's no people in that category. So if I use my calculator to total up all of these people, and then we should get a total number of people so that I can calculate the average. Okay, so this comes out conveniently to a total number of people of 1600. So the mean people per car is equal to total number of people, which is 1600, divide by the total number of cars, which is 800, and so I get an average of 2 people or 2 persons per car. Why are we looking at this example? Well, actually, when we work with statistics and we calculate the expectation or the mean for a discrete random variable, we follow a very similar method. Okay, so this is how the expectation is defined. To find the expectation of a random variable, we sum the result of multiplying each outcome value by the probability of that outcome occurring. A little bit like we did the number of cars times the number of people. And essentially what we do is we sum this all up. So if we look at example 2, example 2 says a discrete random variable x has the following probability distribution. So here's our probability distribution. I want to find the mean for x. So when I'm finding the mean for x, essentially I am finding the expectation, which is defined as adding up all of the values, so these are our x values, times by their probability. So 1 times 0.2 plus 2 times 0.1 plus 3 times 0.2 plus 4 times 0.4, and then finally plus 5 times 0.1. Now, all I have to do, first of all, is show this calculation. So that's the probability times its value. So 1 times 0.2, etc. So look, each corresponding column essentially in the table, and then sum them all up. When I do this on my calculator, we get an expectation of 3.1. So the mean is 3.1. Okay, well I hope that made sense. Here's one for you to try. So we have the discrete random variable x has the following probability distribution. Now I want you to find the mean for x. So at this point, I'd like you to pause the video until you finish the question, at which point resume and we'll cover the solution. Okay then, so let's have a look at the solution. The mean, remember, is our expectation. This is calculated by multiplying each of our values, so 0 times its probability, 0.05. And we just work along one column at a time, summing them up. So 2 times 0.15 plus 4 times 0.4 plus 6 times 0.15 plus 8 times 0.25. And it's really important when you do this that you show your calculation, because in the mark scheme you will be given your method mark or your initial method mark for this calculation here, and without that method mark you can't then get the answer mark, which would be for the answer 4.8. Let's just make a note and we can state that that is the mean. Okay, well I hope you got that question right. So let's extend this idea a little bit further. Let's look at finding the expectation of x squared. Now the expectation of x squared is very similar to what we did a moment ago, except this time instead of multiplying the probability by x, we're going to multiply the probability by x squared. So let's see how this works out. The discrete random variable x has the following probability distribution. So here we have our probability distribution. I'm asked to find the expectation of x squared. So expectation of x squared, as I mentioned a moment ago, it changes very little from the expectation of x, except this time I'm going to do 0 squared times 0.3. So that was the value squared times the probability. So then I get 2 squared times 0.2. Value squared times the probability. I get 4 squared times 0.1 plus 6 squared times 0.3, and finally plus 8 squared times 0.1. Again, your first mark in the exam is given for calculating, writing out the calculation that is required in order to calculate this expectation, and then finally you're going to get your answer mark, and if you do this on your calculator, check it for yourself, you get an answer of 19.6. Okay then, well let's move on and let's give you one to try. The discrete random variable x has the following probability distribution. I want you to find expectation of x squared. So I want you to pause the video, attempt this question for yourself, and then I will resume the video and I will go through the solution. Okay then, so let's have a look at the solution. Expectation of x squared. First I want to get my method mark. So write out the entire calculation. 1 squared times 0.25 plus 2 squared times 0.3 plus 3 squared times 0.1 plus 4 squared times 0.2 plus 5 squared times 0.15. Again, notice that I've written out the entire calculation. I've not done any mini calculations or anything along the way. I'm just showing the actual substitution stage. This can then be typed into my calculator in one go. I don't need to see anything more than this substitution stage. And then when I work through this, you should get an answer, hopefully, of 9.3. Okay, I hope that made sense. I hope you've been able to follow it so far and that you're getting the right answers, because we're now going to extend this a little bit further. Variance. The variance of a random variable x measures how far the distribution of the outcomes is spread out. The variance of 0 indicates that we get the same value for all outcomes of x. So let's start with this final statement. A variance of 0 indicates that we get the same value for all outcomes of x. What this means is, if variance increases, all the values for x, all the values for the outcomes of x get further and further away from what is our expectation. So the higher the variance, the more varied the outcomes are. The lower the variance, the more consistent the outcomes are. Okay, so let's look at how we calculate this. The variance of a discrete random variable x is defined as the expectation of x squared minus the expectation of x squared. Now, sometimes we write this in the following format because it can help distinguish between the expectation of x squared, take away the mean squared, which is what we're saying here. Okay. We've also got this little bit of notation just to notice that the variance is signified by sigma. This is a lowercase sigma squared. Another definition we need to look at is the standard deviation. The standard deviation is the square root of the variance, so that's denoted by sigma, and that's equal to the square root of variance x. Let's have a look at calculating these new things that we've met. Okay, so example 4, we've got discrete random variable x. We're given its probability distribution, and we are asked to find the mean, the variance, and the standard deviation. Okay, well, let's go through this then. So starting with the expectation of x because I want the mean. So we get 0 times 0.1 plus 1 times 0.3 plus 2 times 0.4 plus 3 times 0.2. Okay, now if I work through this, remember once I've shown the substitution, the working, and got my method mark, all I need to do is actually plug this into my calculator and come up with a value. No intermediary steps are needed, and I get the expectation of x is 1.7. Now for the variance, I need the expectation of x squared. So we're writing out almost identical to what we've done above, except this time all my x values are squared, so 0 squared times 0.1, 1 squared times 0.3, plus 2 squared times 0.4, plus 3 squared times 0.2. And so again, at this point, I've shown my substitution. Let's just put this into a calculator and evaluate it in one go. You get an answer of 3.7. So now at this point, I can calculate the variance of x. The variance of x is given as expectation of x squared, which is 3.7. Take away the expectation of x, so here's my expectation of x squared. So 3.7 minus 1.7 squared. When we carry out this calculation, we get an answer of 0.81. So I've now got my expectation of x, I've got my expectation of x squared, I've got a variance, and finally I want my standard deviation, which really I'm going to put in brackets because I should use sigma. That's equal to the square root of the variance, so square root of 0.81, which gives me 0.9. Okay, well I hope those steps all made sense. We're just really pulling everything together now. You'll notice that lots of the steps are really similar. So it's a nice aspect of discrete random variables because this is the same for every question, regardless of whether it's in the exercise or the exam. Time for you to try one. The discrete random variable x has the following probability distribution. I want you to calculate the mean, the variance, and the standard deviation. So pause the video, have a go at that for yourself, and then resume the video to watch my solution. Okay, let's look at the solution then. So first of all, starting off, as we saw a moment ago, I need to do my expectation of x. This is 2 times 0.15 plus 4 times 0.35 plus 6 times 0.3 plus 8 times 0.2. This gives me an expectation of x of 5.1. Let's do the expectation of x squared. Essentially the same as what we've done before. Now, although it's essentially the same, remember you've still got to show this calculation to get the method marks. So 2 squared times 0.15 plus 4 squared times 0.35 plus 6 squared times 0.3 plus 8 squared times 0.2. Now if we work through all of this, enter it in your calculator in one go and then just state the expectation of x squared is 29.4. Now I can calculate the variance of x. Remember that this is the expectation of x squared, so that's 29.4. Take away the expectation of x, or take away the mean, which is 5.1, squared. When I carry out this, I get an answer of 3.79. Okay, finally, standard deviation is the square root of the variance, so square root of 3.79. So carry that out in my calculator, we get an answer of 1.95 to 2 decimal places. Well, I hope it's all made sense so far. More importantly, I hope your answer that you've attempted on this question has matched up, ready so that we can move on. Okay, moving on, we can look at functions of random variables. Now, we've actually already seen how we can do the function of a random variable, but let's introduce it formally. For a discrete random variable x, taking the values xi with probabilities pi, so that means these are the different values of x, and these are their matching probabilities. The expectation we've seen of x is given as the probability, pi, times the value of x. If I get some sort of function g of x, for example, x squared, then to find the expectation of that function, I do the value of the function, once x has been substituted into it, times the probability. So expectation of x cubed is a summation of the x values cubed times the probability. The expectation of 1 over x is given as the value of 1 over the x values times its probability. And we've actually been doing this already with the expectation of x squared. So really this isn't particularly new, it's just formally introducing it to use with other variables. Let's look at this example then. A discrete random variable x has a probability distribution shown. I want to find the expectation of x cubed, and the expectation of 1 over x. Let's start with the expectation of x then. Pretty standard really. 1 times 0.1 plus 2 times 0.3. At this point, hopefully you're getting fairly familiar with what we're doing. You might have even found it a little bit repetitive, but that's fine because that shows you're getting used to the idea. Okay, so you can see I've done each of the values times its probability. Again, I've shown a method to get the method mark, and now if I use my calculator, I should be able to type this in one go, and when I do that, we get an answer of 2.7. Okay, now let's do the expectation of x cubed, I believe it is. Yes. So expectation of x cubed. Now what we're going to do is we're going to cube each of these x values, so that's the function. So 1 cubed times the probability. And this, you can see it's exactly the same as x, what we did for expectation of x squared. So 2 cubed times the probability plus 3 cubed times the probability plus 4 cubed times the probability. Now, when I type that into my calculator all in one go and evaluate it, should get a value of 26.1. Finally, expectation of 1 over x. Deal with this exactly the same. Yes, it's slightly different because we've got a reciprocal, but it's exactly the same. So what I'm going to do is I'm going to say, okay, 1 over my x value, which is 1 over 1, times the probability, 0.1, plus 1 over my x value, which is 2, times the probability, which is 0.3, plus 1 over my x value, which is 3, times the probability, 0.4, plus 1 over my x value, which is 4, times the probability, which is 0.2. Again, you need to show the working to get your method mark. Once you've got your method mark, you may be awarded your answer mark. Type this into your calculator, and actually, when I work this on my calculator, I get an answer of 13 over 30, which can't be expressed as a terminating decimal, so I'll just leave it as that because it's an exact value. Okay, well I hope this example's made sense because it's now time for you to try an example for yourself. So here's the example for you to try. We've got a discrete random variable, has the probability distribution shown in this table. You are asked to work out the expectation of x, the expectation of x squared, and the expectation of 1 over 2x. What I'd like you to do is pause the video and have a go at this for yourself, and then resume the video once you're done and check your answers against my solution. Okay then, so let's look at my solution. Expectation of x. This one you should be fairly confident and comfortable with now. Just the x value times the probability, summing them all up. So just working through one column at a time, 6 times 0.3 and plus 8 times 0.2. When I work through this on a calculator, having demonstrated all my method, I get an answer of 5.1. Next, e of x squared. So fairly familiar with these already. So we've got 2 squared times 0.15 plus 4 squared times 0.35 plus 6 squared times 0.3 plus 8 squared times 0.2. Demonstrated our working for a method mark. Now let's use our calculator to get an answer to this. You should get an answer of 29.8. Finally, expectation of 1 over 2x. So very similar to what I did a moment ago, except this time I'm going to do 1 over 2 times the x value. So I get 1 over 2 times 2, which is 4, times 0.15. Plus 1 over 2 times 4, which is 1 over 8, times 0.35. Plus 1 over 6 times 2, so 1 over 12, times 0.3. Plus 1 over 2 times 8, so I get 1 over 16, times 0.2. Let's plug this into our calculator and evaluate it, and when you do so, hopefully you've got an answer that is equivalent to 19 over 160. Okay, well, hopefully you're happy with everything so far. We have one final thing to look at when exploring expectation and variance for discrete random variables, and we're going to look at that now. So far we've looked at functions of x which were non-linear, so x squared, x cubed, 1 over x, 1 over 2x. However, now what we're going to do is we're going to look at what happens if we've got a linear function. Now if x is a random variable and y equals ax plus b is another random variable where a and b are constants, so this makes it a linear function, then the expectation of y and the variance of y can be found from the expectation of x and variance of x. Before we do that though, let's do this by first principles and the method that you already know. In my example, we've got a discrete random variable x. It has a probability distribution where probability of x equals x is 1 is equal to 0.1, probability x is equal to 2 is 0.6, and probability x equals 3 is 0.3. We're told then the random variable y is defined as y equals 5x plus 3. So we want to find the mean and variance of x and y. Okay, so before we start doing the mean and variance, let's actually define our y values. Our y values we were given as 5x plus 3. So 5 times 1 plus 3 is 8. 5 times 2 plus 3 is 13. And 5 times 3 plus 3 is 18. Okay, so what we have at this point is what our x variable values are and what our y variable values are. So let's find the expectation of x. I get 1 times 0.1 plus 2 times 0.6 plus 3 times 0.3. Work that through on your calculator, you should get an answer of 2.2. Expectation of x squared, because I'm looking to find my variance, so I get 1 squared times 0.1 plus 2 squared times 0.6 plus 3 squared times 0.3. Now, if we type this into our calculator and work this through to evaluate it, get an answer of 5.2. So my variance of x is equal to the expectation of x squared, which is 5.2. Take away the expectation, or the mean, 2.2 squared. If we put this into our calculator and evaluate it, we get the variance of x is 0.36. Okay, let's have a look at doing the same for y. So expectation of y. Exactly the same process, we just got different values for y. So expectation of y is 8 times 0.1 plus 13 times 0.6 plus 18 times 0.3. Type this into our calculator and evaluate this, we get an answer of 14. Now for the variance of y, I need expectation of y squared first of all. So I get 8 squared times 0.1 plus 13 squared times 0.6 plus 18 squared times 0.3. Now if we calculate this on our calculator, you should get an answer of 205. So that when we find the variance of y, I get the expectation of y squared, which is 205. Take away the expectation of y, or the mean, which is 14, squared. And when you put this into a calculator and work it through, you get an answer of 9. Okay, so nothing's changed really at this point in time. But let's just recap our answers. We started off knowing that y equals 5x plus 3. Now, we calculated expectation of x was 2.2 and the expectation of y equals 14. Notice that if I do 5 times 2.2 and add 3, 5 times 2.2 is 11 plus 3 is 14. Also notice that if the variance of x is 0.36 and the variance of y is 9, if I was to do 5 squared, so the 5 coming from there, and multiply it by the variance of x, which is 0.36, you get an answer of 9. That means we can make the following statements regarding linear functions. For linear functions, the expectation of y, if y is defined, and this really we should have included this as ax plus b, then the expectation of y is equal to the expectation of ax plus b, which is equal to a times the expectation of x plus b. The variance of y is then equivalent to the variance of ax plus b, and that's calculated by doing a squared times the variance of x. So just a couple of examples left now because we nearly covered everything. Let's have a look at how we could use this. Now, in this question, I've got a discrete random variable. It has a mean of 2 and variance of 3. I want to find the expectation of 2x plus 1, expectation of 4 minus x, variance of 2x plus 1, and variance of 4 minus x, and then finally the expectation of x squared. Okay, so let's work through this. Oops, one moment. So we started off, we were told that the expectation of x is equal to 2, and that the variance of x is equal to 3. Now, if I was to calculate the expectation of 2x plus 1, the way I would do this is I would do 2 times the expectation of x plus 1. So I get 2 lots of 2 plus 1 equal to 5. Similarly, if I wanted to calculate the expectation of x as being equal to 4 minus x, I would simply do 4 minus the expectation of x, which would give me 4 minus 2, and actually it comes out the same, it comes out as 2. Now notice in this example I didn't actually have any of the values of x, and I didn't have any of the probabilities of x, yet I was still able to calculate these values, which is why these definitions are so powerful. Let's do the variance. The variance of 2x plus 1 is equal to the coefficient of x, which is 2, squared, times the variance of the original variable. So I get 2 squared times 3 So I get 4 times 3, which is 12. The variance of 4 minus x, done exactly the same way. This time the coefficient of x is minus 1 squared times the variance of x. And so minus 1 squared times by 3. Minus 1 squared is plus 1. And so I get that while the expectation was the same, also the variance was the same. And this is just a peculiar function. But again, notice how powerful these definitions are, because I've managed to calculate these new variances without ever knowing what the x values are and the probabilities. Finally, I'm told that I want to find the expectation of x squared. Now, I've got the expectation of x squared. I know that the variance of x is equal to the expectation of x squared, take away the expectation of x all squared. So if I rearrange this by adding expectation of x squared, what I get is that the expectation of x squared is in fact the variance of x plus the expectation of x squared, which is 3 plus 2 squared. So there's my variance of x, there's my expectation of x squared. So we get the expectation of x squared is 7. Okay, well, I hope you was able to follow all my examples there and that you understood what I was doing, because now it's time for you to attempt the last question of the lesson. A discrete random variable x has mean 2 and variance 9. I want you to calculate expectation of 3x plus 1, expectation of 2 minus 3x, variance of 3x plus 1, and a variance of 2 minus 3x, and again calculate the expectation of x squared. So I want you to have a go at this now, and then while you're doing that, pause the video, resume in a moment once you've finished the questions, and check your answers against my solution. Okay then, so let's have a look at my solution. Just a note quickly, expectation of x we stated as 2, and this time we said the variance of x was equal to 9. So starting with expectation of 3x plus 1, I get 3 times the expectation of x plus 1, so I get 3 lots of 2 plus 1, so 6 plus 1 is 7. I can now do the expectation of 2 minus 3x. So we get 2, take away 3 lots of e to the x. So 2 minus 3, let's quickly adapt that, 3 lots of 2 equals 2 minus 6, we get an expectation of minus 4. Now let's have a look at the variance. Variance of 3x plus 1 is given as the coefficient of x, which is 3 squared, times the original variance. So we get 3 squared times by 9, so we get 9 times 9, which is 81. Do exactly the same for the variance of 2 minus 3x. So coefficient of x again is minus 3 this time, but I'm going to square it, times the variance of the original variable. So I get minus 3 squared times 9, which again is 81. Again, this is pure chance, this just happens to be the examples that we're looking at. Finally, I want to find the expectation of x squared. I'm going to do that using the definition for the variance of x, being expectation of x squared minus the expectation of x all squared. So we know that we can rearrange this, so the expectation of x squared equals the variance of x plus the expectation of x squared. Okay, so expectation of x squared can be found by doing 9 plus 2 squared, so we get an answer of 13. Okay, again, I hope you managed to follow my solution, and more importantly that your answer has matched up, because that has now covered everything in the expectation and variance of discrete random variables. At this point, it's time for you to complete some independent study, so work through the exercises. The exercises contain an exercise on expectation, an exercise on variance, and then an exercise on the functions of linear functions of x. So work through those until you feel confident. Once you feel confident, have a go at assessment 7. Okay, that's it for this S1 lesson. I hope that it all made sense. I hope you was able to follow it, and I hope that you've understood what we're doing and are able to apply this for your own self now.